Hello everyone and good afternoon to all of you. Today we have problem which name is number of ways to divide a long corridor. Lead code 2147 problem. So before going forward in this video, please make sure that you have liked and subscribed to this channel, and also it's my advice to all of you that please read the problem carefully and try to build up the intuition in your mind, and also try to do after making the intuition, try to do the code. And if you simply see this video then do the code, then it will not beneficial for you. Means firstly try by yourself, then see this video, then it will be beneficial for you. So let's read the problem statement. See, here is written that it's a hard problem, but it's not a hard problem, it's a upper than the medium problem. So let's see what question is saying, that along a long library corridor there is a line of seats and a decorative plants. The seat that seats is denoting as S and plants is denoting by P, and the corridor length is N. One room divider has already been installed to the left of the index 0 and another right of the n minus index n minus 1. Additional room dividers can be installed for each position between indices I minus 1 to I. Okay, done. It's I is going from 1 to n minus 1. Divide the corridor into non-overlapping sections where each section has exactly two seats with any number of plants. Means each section should be exactly two seats. So first, this is the important condition, and there may be a multiple ways to perform the division. Two ways are different. If there is a position, then with a room of divider install this one, and we have to finally modulo. Actually we have to find the number of ways. Okay, so let's think how we will do this. So firstly, as you can see, here is a line that is saying there are exactly two seats. Means each divider has exactly two seats. So let's think, if each divider has as exactly two seats. So if my number of seats is odd, means if my number of seats is odd, then what I will do? If my number of seats is odd, then I will what I will do? If my number of seats is odd, then I can't do anything. Means if the number of seats should be even, means each divider has exactly two seats. Let's think the approach and see, then we will understand. Let's see. See, the first condition is each divider has exactly two seats. So what about if my number of seats is odd? Like let's say if my number of seats equals to 5, so it can't be possible. Means फर्स्टली अगर मेरे 5 सीट होगा तो मेरे को टू डिवाइडर बनाने हैं. मीन्स हर 2 सीट के बाद एक डिवाइडर आना चाहिए. एग्जैक्टली 2 सीट्स के बाद डिवाइडर आना चाहिए. तो डिवाइडर आ जाएगा, फिर एग्जैक्टली 2 फीट के बाद डिवाइडर आ जाएगा, फिर एक सीट बचेगी, 2 + 2, फिर एक सीट बचेगी. वहां पे डिवाइडर नहीं आ सकता. मीन्स और सीट के लिए हम ये नहीं कर सकते. Now, if my seats equals to 0, if my count of seats equals to 0, then also I can't do anything. So I have to return 0. Okay, then it's this case is also done. Now see, if my seat structure is like this: seat, then here plant, then seat, then plant, then seat. Then see, my whenever my two seat will encounter. Okay, see this. Listen this statement. Whenever I will encounter by my two seats, okay, then what I will do? I will put my divider. I will put my divider, and until my third seat will not come. Means you will replace first seat. You will replace first divider after encounter the two seats. You will replace first divider after encounter the two seats. Let's see. यहाँ एक सीट आ गई, यहाँ पे भी सीट आ गई. And now I can divide. Now I can put my divider here, because I can put my divider after encounter the two seats. So before going to third seat, I can put my divider. So here are some cases: first seat, second seat, and third seat, like this. And finally what I will do, I will each divider, here is the n choice, then again n choice. So I have to multiply these for finding out the number of ways. Now see, what about when plant will come? Then if my plant will come, see, If my array is like seed, seed, then plant, then seed, then seed. So as you can see, whenever my plant will come, if one plant will come, I have to put my two dividers because I have to cover this area. So I have to put two dividers. If my two plant will come, I have to put three dividers like this. If now, what is the base condition for this? If my number of count means up count seeds equals to 0, or if my count seeds are odd, then I will put 0, otherwise I have to return my answer. So answer will be like this: whenever I will encounter two seeds, I have to put my divider. So this will be my current index and this will be my last index. So current index minus last index will give me the number of dividers. So it's like that. Let's do the code so that we can understand properly. So firstly, I have to define long. So let's say define long int, and also I have to define modulo. So as a define mod equals to 1 2 3 4 5 6 7 8 and 9. Done. Now what I will do is I have to declare our answer int answer equals to 0. Finally I will return my answer as multiplication. So and int, so answer should be in long term, and int n equals to corridor dot size. This is the, and I have to keep track of last index. What is my last index? Because current index minus last index should be my answer. And when I will see my last index, whenever I will encounter the two seeds, and then I will see the last index minus current index, because now I will see third seed. So third seed and second seed, in between of them, I will put my divider. So int n equals to corridor dot size and int last index equals to -1. This is done. Now I have to keep track of my seed count also whenever my seed count is greater than 2, because less than 2 I can't do anything. Greater than 2, greater than equals to 3 also. So int seed count equals to 0. Now I'll apply a loop and see int I equals to 0 to I less than n, then I plus plus. Now I'll check if my corridor of I equals to plant means corridor of I equals to plant. Now what I will do, I will simply continue because plant से कोई दिक्कत नहीं है. Simply continue, and I will increase our last index also because I have to keep track of last index minus current, means current index minus last index. So I have to increase this last index plus plus. And now what I will see, if my seat count is greater than 2, because less than 2 I can't do anything, and seat count modulo 2 equals to 1. It means I am at the whenever I will reach at the third index, third seat, then I will see my current index minus last previous index means last index, because after two seats I will put my divider. So second and third, before going the third seat, I'll put the my divider. So I have to check that if a seat count modulo 2 equals to 1. Let's take a third. So seat count equals to 3. 3 modulo 2 equals to 1. Now I have to stop. I have to check my int divider equals to current index minus last index, and our answer will be like answer equals to answer multiply divider, and finally up to do modulo also. This is it. and no, it should be last index equals to I. Last index equals to I, and I have to increase the seat count here, because whenever I encounter the seat, I will increase the seat count. So seat count plus plus. This is the now I'll check. I have to return if a seat count equals to 0, and yeah, seat count modulo 2 means seat counts are odd. Seat count modulo 2 equals to 1. In this case, I will return 0, and otherwise I will return my answer. So let's run this code and see if this will work or not. It is working perfect. Let's submit this. As you can see, it is working perfect. Let's discuss about the time and space complexity for this. So here, as you can see that we are not taking any space, we are only using the variables. So space complexity will be big of 1, and the time complexity will be big of n, because we are iterating the whole array, we can say, or corridor string. So time complexity will be big O of n, and space complexity will be big O of 1. Here can be another method also. We can use a DP in this case. Then it will be something harder problem. So if you find this helpful, then please like, share, and subscribe. And if you know another approaches for this, then you can comment.